It's not a you thing, it's a me thing. For some reason, YouTube will not allow me to do it. Anyway, take it easy, y'all. We'll see you tomorrow. I'll see you over on down on the Maker stream.
Good morning, everybody, and thanks to Projects in Dad's Garage. He's just finished his stream and kicked everybody over to here. I understand he couldn't actually do a proper raid-in because something's not quite set up right, but that's no big deal. Thanks for handing over anyway, Projects, and thank you for the plug. Hopefully, everybody will be here in the next couple of moments. Just give you a few moments to get there. Get rid of me off my screen. Now, things might be a little bit jank because I've just had to hand off my little guy to Mrs. Maker because daycare wasn't able to take him, and just a whole mess of things. So I haven't had my usual time to actually get the stream fully set up. If suddenly things disappear off the stream in terms of a black screen, it's probably because I'm hiding something from a beta test that I'm doing. I've got 3 or 4 beta tests going on concurrently at the moment, and obviously I can't show you that stuff because it's all under NDA. What I will tell you is it's all very cool and it's all coming very soon, so there will be little hints as we go because I have actually changed my mind on some of the things we're going to be doing to the end of 5 to allow me to then use some of this gear on an ongoing basis once it's actually available and publicly launched. So, where are we at? Let's go to that one. And wait a minute, one of those cameras isn't working properly. I'll fix it in a minute. What we have is my Rapid Burner. Off screen, I fixed a couple of little bits and pieces that weren't quite right with it, and I'm pretty happy with how it's going at this point. What we need to do today is properly mount the mounting plate onto the Ender 5 V-wheel dolly, and then we need to start wiring things up. We are going to be using the Bigtree U2C as the CAN bus interface. There. Let's move that across so they more or less line up. That's better. So we're going to be using that as our CAN bus interface. We're still going with the SKR Pico on the for controlling the Ender guts, and we've got some wiring to do. Now, like I said, I can't discuss all of what's going on and the reasons behind it, but what I can tell you is I've got some very exciting products that I'm testing, and in order to be able to integrate them into this machine later, which I really do want to do, I'm going to be putting some stuff in place that I can show you that I can't talk about why. So you just have to cope with that fact, and we will go from there. Now, I have put some stuff down somewhere that I'm going to need, which is my crimpers and things, so I'll have to grab that in a few moments. But what we need to do first of all is we need to wake up that missing camera. Wake up all devices. And it's back. There we go. It's called side cam. Where's it gone? Please. Okay. It's doing its thing where it doesn't like talking to things, so I'll quickly reboot it. This one camera has been not playing as nicely as it should do with some of my stuff. So let's just see if we can work around that and go there. Yeah, it's not really talking to anything. Okay, so what are we doing that's different? We're going to be installing a 5-volt power supply. 5-volt, 5-amp power supply. which is initially going to be used to power the Raspberry Pi that's on board. Its longer term job will be different, but rather than powering the Raspberry Pi off the Pico, I'm going to be using this power supply, and then it will be then retasked to do what I want it to do later on. So let's see if that camera's woken up again. Nope. Let's see if I can plug it in on a different cable and it'll respond. Okay. Meantime, let's try this other camera so that we can see the end of 5 better. And go here. Nope, wrong way. There we go. Down a bit more. There, and I think I'm going to bring it down a little bit. Now, hi Jason, hi Digital Dragon, hi projects. I know Brad had to bail because he's got some crane thing going on tomorrow morning really early, so we shall miss him, and he can catch us up in video on demand later. Now, because the way this is going to be done, we relies on having the top of the power supply box put back on. I'm just going to use VHB tape to hold in my power supply. It's not going to need any more than that. It's basically sandwiched in with a small spacer that I'm going to apply to the cover. And for those of you who haven't been here since the beginning of this project, the power box has actually been inverted. I inverted it some time ago because it just makes getting into it a lot easier, and you don't have to roll the printer over to get into the electronics. So basically, instead of the power box being the other way up with the steel across the middle here, flipped it over, mounted it upside down. That means that the power switch has been moved to here. A whole bunch of macro buttons here, which I think is one of the Phaetus button sets. I can't remember, it's a long time ago since I installed it, and I just never got around to setting it up. So that's one of the things that we're going to be doing. On the subject of macro buttons, a long time ago in a stream far away, I won a Big Tree Tech HBB Founders Edition macro button set, and I've just recently found a use case for it that I think is going to be useful for, and that is bolted to the front of my box turtle. Why, you ask? Well, I'm finding that currently how I'm using it, I really could use some buttons right there, and as a result, I think that's going to be the best way to do it, is to have some macro buttons actually screwed to the front of the rails to give me a bit better access. That's looking nothing like the Ender 5 that they have at the middle school across the way. This is the original Ender 5 Pro. So I got this within a couple of weeks of the Ender 5 Pro launching. It was one of the first ones with the silent drivers, and what else did it have that was special? It had something else that was special compared to the original version. So that's why I ended up buying this. It was my first 3D printer, and it was the gateway drug, as most Enders usually are. Now, while I've got the VHB tape out, I'm also just quickly applying a few small squares of VHB tape to the mount for the U2C. I know you can't really see it. Let's go to, yeah, you can sort of follow me at the same time. And one last little bit. Now, why am I using filament snips, you ask? Because I realized just as I was coming on stream that I'd put my scissors in the dishwasher that I use in here because one of the kids had asked me to open a yogurt and they'd pulled the tab off it. So I used the scissors to stab it and got them messy. Typical dad things. Actually, let's put all this on pause. That is the HBB EBB macro button thingy from Big Tree Tech. There was two versions when they did it. The Founders Edition, because everybody was doing Founders Editions, NVIDIA, etc. at the time. And they made the PC board translucent because they could. It looks kind of cool. I'm not sure that it adds anything, but yeah. And I'm just using the standard front cover. I found some green translucent PLA that I really wanted to try out, see how it looked in my stash, and it kind of goes with the theme of the box turtle if it's a little tiny bit stringy. And yeah, green translucent box for it. This is a slightly modified original back cover for that. I've just simply added two tabs top and bottom so that I can go it straight to the rails on the front of the box turtle, and we can work out logistics a little bit later. So next step, we need some mains power for this 5-volt power supply. Now, this has been disconnected from the mains power for quite some time, so it's definitely going to be safe to play with the mains on this now. Some people don't realize that inside the power supplies there's big fat whopping capacitors, and just simply turning the power supply off and then playing with things, you can still get a big fat boot off them. So always, 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 if in doubt, leave the load connected to the power supply. That will then allow it to discharge any capacitors inside the unit and keep you safe. I'm going to leave that there for a minute. Right. So what I've got is I've got mains rated cables. I've already pre-crimped that end, ready for the 5-volt power supply. And I need to work out how I'm going to connect this to the high voltage side of the power cabling here. There is a crimp there that's already available for the active. So I really just need to make up something to connect to the negative, I think. Yes. So what am I looking for? I'm looking for all my crimps. I had a box of them. What did I do with them? And this is what happens when Phil gets rushed. There we go. There's the big box of crimps. And I need a spade type terminal. That should be the right gauge. And I'm going to need some heat shrink because I don't mess around when it comes to mains. For those of you who haven't caught my streams before, I actually teach high school electronics and engineering and science. And as a result, some of my students occasionally do roll across my streams. And to keep them safe, I'm going to do things the best possible way and the safest way. When it comes to mains electrical. Now, mains electrical rules vary by jurisdiction. Here in Australia, anything after the plug within reason is fair game. But before the plug, we're not allowed to do any electrical work like in the walls or sockets or anything like that. Some people do, but they're risking their home insurance and safety by doing so. So I won't be doing any of that. Just make sure that that's the right terminal fit. Yes, it is. So that doesn't actually need to be particularly long. About there. Wire strippers. No, that is the right gauge. Now, when you're dealing with these kind of terminals, best practice is to always have maybe 1 millimeter or 2 millimeters just of the copper poking through the very end. A different point of view on students on. I wired half the power in my garage, all 220 volts. You do you, dude. You do you. I'm just looking for my crimpers. I know I've got them here somewhere. Pliers? No. The reason I'm looking for my crimpers is I want to do this properly. When it comes to crimping these style of terminals, most people do it the wrong way around. Let me explain. Actually, where's one I can sacrifice? Will it tear the right way that I need it to? Not easily. It is starting to pull off. That's what I needed it to do anyway. There's my other pliers. And I've just spotted where my good crimpers are, so that's awesome. So, this is the naked crimp. On this side, there is a split where they've literally stamped these out of a sheet of metal, and then they curl up the two edges when they're stamped out like wings. Let's show you properly. There we go. Close enough. So they're stamped out of a piece of metal, then they look like this. They then curl up the two wings so that they're pretty much butt jointed together. When most people are crimping these terminals, they expect to crimp the terminal in such a way that they'll be pressing down using the crimper on the join. Not the right way to do it. If you're doing it properly, you'll be pressing on the bottom side of the crimp and squeezing that up into the rolled up part of the terminal. Let me explain. Here's the jaws. The join on this one will be here, away from the terminal. So what I need to do is I need to align it in such a way that the pin that will be pressing into the terminal to crimp it will be here on the pressing into the full steel part, not the joint part. I know I'm probably not just explaining this as best as I possibly could, but any explanation is better than no explanation when it comes to this stuff. And as a result, there is no way that that terminal is coming off. And as you can see, I did exactly the same on that one when I was preparing it earlier. Basically, I didn't want to do a crimp on stream with you guys and then realize that I'd stuffed it up. So I double checked my technique before I did it. So where are we at? That is now our active terminal. Live is there, so that screws into that one. And I'm going to screw the terminals down now. I'm just going to prepare all the wiring first, and then we'll do that in a minute. But I will just quickly plug those two together and test fit. There. So that is a really nice direct cable run. Now, you probably can't see it from there. Let's, can't do it easily. Let's see if we can wheel this in a bit. and zoom out. Can't quite make it out. Okay. Can you now? Ah, just here, some relays. The relays are set up in such a way as to be normally connected. So it's a normally closed circuit. The reason being is, if anything fails, it will leave the printer running. Wanted that for a very specific reason. What I can now do is I can connect the control part of the relay to a Raspberry Pi GPIO, and I can then use that to drag the relay from normally closed to open circuit. That means it will then shut down the 24-volt power supply. The power supply I've got in this unit is actually an always-on fan, because that's what was in these original versions. And it's noisy. I don't want it to be running all the time. So this means I can actually kill the 24-volt power supply, which means it doesn't make all that noise, and I'm much better off for my sanity. Next step. We need our neutral wire connecting. Now, how am I going to do this? How is it currently connected at the power supply? Grab my screwdriver. I really wish this other camera was working. It would make life a lot simpler. So what I'm doing now is I'm unscrewing the terminal at this end to get access to the neutral, and that's just a spade connector and a spade crimp, a fork connector and a spade crimp. I think the best way to deal with this is to remove it and modify that cabling just slightly to give me effectively a Y cable and go from there. So where are my pliers? There are my pliers. So that's what was in there. Hi, Clownhammer. Hi, Cody. Having a look. Had to fix a few dozen things the electrician who did the last remodel in the house did. Yeah, I've seen some of the travesties of electrical that pass for normal in the US, and it's scary. And how the heck you guys still get away with wire nuts when the rest of the world abandoned them is, yeah. Still on the plane, taxiing to the gate. Where are you? You're going to Colorado, I think somebody mentioned. So what am I doing? I need to make up a Y cable. How am I going to do this the best way? I've got lots of extra here. So chop that and open this. I'm trying to work out the best way to do this safely. And I can't think of a way to do it safely that's not going to involve a Wago. Reason being, the way they do their terminals is they strip off all the insulation and then they heat shrink them. And I don't like doing that. I mean, I guess I could do a soldered joint. No, don't want to do that, it's mains. Now, for those of you who haven't been to my previous streams, I'm trying to do this stream as I've got it planned out in my head, but I'm doing it along with you guys as we go. I don't want this to be like a fully planned out stream. I want this to be a kind of an organic thing where we're developing the solutions as we go. That may sound like a cop-out and that I'm just not doing any planning for my stream. It was really more of a, I want to do this as an experience for people who are tinkering and doing their thing that way. So how can I do this that's reversible? That's probably a better way to ask this question. I know how we can do it. Let's put a spade connector onto that one. And again, practicing what I preach. Aligning that. And crimp. Doesn't feel as secure as I'd like it to, so I'm just going to give it one more tweak. Much better. Too short. See, on my streams, I explain how to do the next to zero of what I'm doing. So, clown hammer. This project is currently using Raspberry Pi 3 and an SKR Pico. A whole bunch of that stuff is going to change. I explained this at the beginning of the stream before you got here. A whole bunch of that is going to change because I've got some beta hardware from a company that I really would like to use on an ongoing basis because I like it. And as a result of that, I'm kind of planning ahead for installing that at the same time as doing what I'm doing. My Unraid server will no longer connect to my network. Right. So this is how I plan to do this. And I'm going to put some Did I put the wrong terminal on here? I think I may have. Yes, that's all right. I can fix that. In case you didn't see what I've done, I've accidentally put the wrong size spade terminal onto that connector, and it doesn't fit. That wire, rather. It could be that Creality have just not crimped these down to spec. It's too much. Okay, so there's two terminal sizes. There's 6.2 and there's 6.3 or 4.2, something like that. And I think this is actually designed for a slightly narrower connector, which it is. I'm just seeing if I can trim this to make it fit. No. Because I really don't want to have to go out and buy even more of these terminals if I can avoid it. Just check what I've got here. Yeah, these are all the wider gauge. Let's check out my box of tricks. That one fits. Not the right way to do it, but it will get us going, and I will have to order some replacements. So where are we at? We need to crimp this onto that wire. So guys, so you know what I'm doing. As a temporary thing, just in case we get to the point where we do need to connect it, I'm installing a fork style connector. It's going to have the same amount of surface area and contact, so it's not going to be a big deal, and we're not drawing huge amounts of current. We're way under the spec of the connector. But in order to keep us moving, I'm going to install this for now, and then I will replace it with a properly spec'd spade terminal this week. So that is connected. That goes into here. That then connects into this one. That it then allows me to connect to the power supply. This, we will strip the end off. That will connect to the 5-volt power supply. Now, it's not in the spec that you need to do this, but what I like to do is I like to actually connect the, where am I going with this? I like to connect the middle terminal of a 3 terminal as the input. That way it's spreading the output current across both directions, rather than having to carry the current across all the way from left to right or right to left, however you're going to plug these in. It doesn't make any difference in theory. It's just the way I like to do it because it keeps things nice. Now, I'm not going to be able to go forward with this anyway because I need to get some more of this mains rated wire from my stash. So let's just leave that there and put that there. Okay. Just like any experiment and any butzing, there's going to be points where you reach the point where you go, ah, crap, I don't have exactly what I need. And I'm at that stage with this particular part of the process. Put that terminal away. So while I regain my composure, let's put the U2C into its spot. That's going to go there. So let's screw it to its base. Now, I don't recall if this is M2 or M2.5. I think it's M2.5. There we go. Let's zoom in a little bit. Don't want to go too far and lose you guys. This should be in 4K. Doesn't appear to be in 4K on my screen up here. Let's just go out a little bit. It could just be what OBS is showing me versus what you guys see. Is the picture quality okay, or is it just awful? That must be done for an M2. I downloaded this off printables, and it appears the M2 is too big. So let's M2.5 is too big. Let's go to M2s. Now the downside of my M2 stash is oh no, I do have some hex head. So what it's done is it's just mangled up that just mangled up one of the holes a little bit. It hasn't damaged it as such. I think it might have taken like the top 2 layers off. For sure it's not 4K. It's set to 4K 30 here. I can't change it at this point. I'll just have to leave it as is. Oh, here we go. Camera 1, output settings. No, can't change it. I will have a play with it. This is the same camera that Steve Bilge uses. This is his side cam. That's a Phillips head. They are all Phillips head. I think I've got a couple more in here that'll work. One. So let's have a quick look at this. These are basically just a whole bunch of different CAN bus output terminals. They might look like USB, but they're actually CAN bus out. That's a GST style connection for it, Molex and Pt3, and also just straight up screw down terminals. The way I like to use these is to have the power input come into here, and I like to use the Pt3 or the Molex as the output to the toolhead board. Let's have a look in our box of tricks what we've got here. So I've got 2 Pt3s, so that's what we're going to be doing. But what I might do is I might just check in my box of tricks, because I have a whole bunch of these cables already made up. Not that one. That one. So, like I said, I do lots of beta testing, and as a result, I have a whole bunch of these cables already done for various projects. So that's already got a Pt3. That will connect onto that one quite happily. I know it's already terminated properly, so we'll use that. Let's get rid of the screwdriver for a minute. Push all this stuff out of the way. Let's put that Pt3 in the box so I don't lose it. Now, one of the things I'm trying really hard to do for you guys is plan in advance. I don't want you to come to my streams and then me go, ah, crap, I've got nothing to show you guys because I haven't planned ahead. I'm doing what I can, but staying within the scope. And I do have the fallback of being able to do the HBB board if we run out of stuff to do. And I've got something else which I could do as well, which I've been trying to hold back on as a separate project. So I won't talk about that yet. Where are we at? We've got the 2 power plugs done. And next we need to do these now. This stripper is awesome, but it doesn't go this small. Now I'm just going to explain to you what's going on with this cable. The CAN bus data lines, the green and the yellow, they are so much finer than the power cables that they break off really easily. So what I do is I actually normally terminate it in such a way as the red and black power cables act as strain relief. That way there's never any real tension put onto the CAN bus ones, which are much finer and much more likely to break. Let's catch up on chat. It may have just cropped in really far. That's what I've done at this point to try and give you guys a better view. I use the same camera, I got everything. But no one uses your affiliate link. I didn't know you had one, projects. I just simply saw that Steve was using one and grabbed it. Don't assume things are done right. That's how I ended up with an $80 beacon paperweight. Yeah. Agreed. So I'm just going to quickly check. It's not listed. The other thing I've just noticed. Let's get rid of, I've got something over what you guys are seeing. I've just noticed I do have the CAN bus pass through, which will allow me to use my eddy current sensor later, but I haven't yet terminated the CAN bus. So I'm going to quickly find a jumper to do that. None in there. There's one. So that's already terminated. We already discussed that the U2C is pre-terminated. Those cable ties are annoying me, so I'm going to snip those while they're there and put that out of the way. So let's get the VTech GitHub up. Close that before you guys see it because that's under NDA, and go for that one. Okay, now I can do that. Let's go to, sorry guys, I'm just, there we go. So what we're looking for is the EBB36V3. Nope, that's not it. Just under EBB. Nope. Let's just straight up Google search it. Much better. So you know what might be better for this? Let's go to Esoterical site. Esoterical goes to great length and USB CAN device. That's what we're doing. Toolhead flashing. Common toolhead hardware. EVV36V. I thought this was a 1.3. Must be the 1.2. Yep, it's the right one. Okay, so reason for getting this, it makes it really hard to get the wiring wrong. So what we're going to need is my crimpers. My microfit crimps. 1, 2, 3, 4. And will we continue my streak of getting this right the first time? That's the question. Not perfect, but it's good enough. Now the good thing is I did just spend some money and bought myself the microfit depinning tool. So if I do manage to screw this up, I can always depin it if necessary. Let's go back to that one for a minute. Yep. Now, because of the way I've cut this cable, I'm not going to have the extra slack that I was talking about on this one, I don't think. But I will try to arrange it so that the one that has the slack available is at the tool head end. Happy with that one, happy with that one, and that one. And that one's probably the best of the lot. So let's jump back to Chrome. Now, I always find it's actually easier to double check this by plugging the plug in. Far less likely to do something dumb if I do it that way. So just double checking against that and that. And black is closest to the board and on that side. That's pushed all the way home and is seated. Next is the positive. Line that up. Now I'm not going to insert that all the way. I'm going to leave that for a moment while I do the two finer wires. Oh, there's one stray strand on that one. Where's my snips? Now, just to the side of camera where it's not going to affect my lighting too badly, I have a magnifying lamp. I'm just using that to see a bit better. There we go. So now we push all of these home and they should just basically click into place. It's more needle nose pliers just to manipulate this the best way. Click. Green has clicked in. And now for the positive, click. If you do these crimps right, you can just feel it go click and it just sits into place and it's good. So that's all in place, all done and ready to use. So the end we've just crimped is going to be the end that goes into the end of 5, and the end that was already pre-crimped, that is going to be the one that goes to the tool head. So let's run this cable through the holes for a moment. Tuck that over the y-axis. Pull this into here and into here. Now, I had been planning to put that there, but I don't think it's going to fit. So I know you guys can't really see this easily, but in the chassis of the power supply, there's actually a couple of spots where you could, in theory, put screws through. I was semi-thinking about using those, but it then means that the CAN bus cable, which comes out of the side of the board, just doesn't fit. So rather than do, actually, it might. Turn it around. Will it fit then? Yeah, that works. Good job. So we're going to mount it that way around. Let's unplug that for a moment. Because what we also need to do is we need to run power from the 24-volt power supply around to the CAN bus board. That one. Now the wire I'm using is crazy over-spec'd for what I'm using it for, but I'd rather over-spec'd and safe. This we need fork style connectors. Just double checking that I've got the right size. Now, that's what I needed. For those of you who don't know, the color of the plastic, it is meant as a signal to tell you what size of cable it's good for. That's a little tiny bit too much insulation off on that one. So again, just the barest 1 millimeter or so of copper out of the exposed end. Do it this way for a change. Dimple to the bottom of the crimp. And squeeze. And that's all nicely seated. Now, I'm sure some of you saw Steve Builds do this the other day. And I would do it if I could find my heat gun. What have I done with my heat gun? Basically, if you overdo it with the plastic, it's a thermoplastic, and you can actually heat it up, and it will relax, and it will then not look as icky, and it will sit back into its nice spot. I don't know where that came from. It's a USB extension cable. I'll try and do this away from my microphone so that it's not annoying you guys too much. That's better. And that's off. So what I've got, 2 crimped forks ready to go onto the 24-volt power supply. That's still a bit warm. And what I need to do now is put some bootlace crimps onto the other end to allow it to connect into the U2C reliably. The trick with bootlace terminals is to find the smallest one that'll work. So you probably won't be able to see it on the screen, but just in here, I can just make out the end of the copper of the wire at the very end of the inside of these bootlace crimps. Now what these are is they're basically a tube of aluminium that you use to tidy the ends of the wire and allow them to be put into screw down terminals and not break and fray as easily. So for this we need 24-volt power and ground. So that's the ground terminal. And that's the positive terminal. And when you do that, it means that there's no chance of any stray wires bridging across between the 2 terminals. Now what I've noticed is these are ever so slightly too long for the screw downs that I'm using. So what I'm doing is I'm just trimming off the last couple of millimeters of these aluminium tubes. We should also take the last little bit of copper with it. And then I'm going to do it again, because that will mean that there's absolutely no metal exposed at the end of the terminals here. Now, do I have my electrical screwdriver here? Yes. Is it narrow enough? Yes. Stood up here so you can see it. And because there's so much purchase on that aluminium tube, and the tube kind of compresses inside the screw down, it means that there's almost no chance of that crimp ever coming out, and there's no chance of the wires coming loose because it's further crimped down by the screws as you tighten the terminals. So that goes into there, that goes into there, and they now come around to the 24-volt power supply. How am I going to run this? I've actually done myself a disservice by leaving too much wire here. I might trim that off stream, I think, but for now, let's get it all wired in. So negative is here. Let's go. So on the power supply, live, neutral, earth, which makes a lot of sense because you keep the spicy one as far from the low voltage as possible. Live, neutral, earth. Then I've got 3 negative and 3 positive terminals. Now the center to the matched pair that are closest together of the negative and positive, they're already in use for the SKR Pico. So I'm going to leave those alone. Don't mess with what's working. Said no printer modifier ever. And negative into place. Now, because you guys won't be able to see this very clearly, I'm just telling you about it. I'm leaving the last terminal next to the earth empty, because keeping your low voltage, or actually technically speaking, extra low voltage ELV cabling away from your spicy stuff is by far the preferred and best method to deal with this stuff. So that's in place. That can now go here. Plugging in my CAN bus. Now, if you remember, I've got the VHB tape on the bottom of the holder. So I'm just peeling that off right now. Now, in case you didn't know, VHB tape, the tape that I'm using, the special double-sided tape, is actually pressure activated to a certain extent. So the more you press on it, the more it sticks. And that goes in there. Now, tuck that down in there for now. What I'm probably going to do is just trim off that loop and recrimp it to make that all nice, but I should do that off stream, because you guys don't need to see that. I have 40 minutes left on my stream. My wife's got a meeting that she needs to take at 12, so I need to be out of here just before that time to be able to grab my son off her. She very kindly took 2 hours off work this morning to allow me to do my stream, because I missed last week and I've been missing a couple of weeks due to bad daycare issues. So that's all in place, that's all in place. Happy with that. So where are we at here? We still need to fix up that negative connection, sorry, the neutral connection to, yeah, we still need to fix up that neutral connection. And then is there another way we can do this? Let's pull this out for a second. So that works. No, that works. That connection fits onto that terminal happily. I've got plenty of those crimps. I'm just going to cut this off. And strip it. And like I mentioned earlier, I'm going to insert that into the middle terminal on the Wago. Which will then allow me to straighten those pins. Hi, Nick. Oh, thanks, Mrs. Maker. Yep, I will thank her for you guys. I'm trying not to have my back to you guys, but I'm also trying to show you what's going on, and it's kind of difficult at this point. Let's see if I can zoom this camera without too many difficulties. Cam 1. Yeah, it gets grainy fast, doesn't it? Hi, Keela. So that needs to connect back onto the power supply. That needs to connect. Sorry, that needs to connect to the power inlet. That needs to connect to the main power supply. That needs to go to the 5-volt power supply. So if you didn't catch that, I've just VHB'd the Wago holder into place. I'm going to realize that I've installed it the wrong way around. That's not a big deal because it's Wagos. I can pop the little flaps open and take the wires out and rearrange them without any major difficulties. One. That just needs squeezing down again. Now, this LRS 300, I think it is, 350 power supply, is a genuine Meanwell, but it was from the first generation of Creality to use them, and it was before they put the safety covers onto the terminals. So I need to print myself a safety cover for these terminals. So that's connected. So we come out of the power inlet, we loop into the Wago. From the Wago, we loop out to the neutral on the power supply, and the other side is looping out from the third point on the Wago. Click him in and make sure he's latched around to the power supply on this side. Now this one does have a safety cover on it, although it's probably not as deep as I would like it to be, but it's all going to be sealed up, so it's not that big of a deal. Do I have any heat shrink? I had my heat shrink out earlier. What did I do with it? Did I put it away? It's over here. next size up, and that'll be the one I'm out of. Always is. It's always the size that you need, you run out of. Yep, it's the size I need, I'm out of. I will worry about the heat shrink later. I wasn't planning on using it anyway. So double check this before I tighten them down. Labeled live, neutral, negative, positive, and there's an earth in the middle. I'm not going to earth it because it's going to be earth straps to the chassis of the LRS. I just don't have any earth marked wiring at the moment, so I'm waiting for that to come in. Up. So, sorry, I know you were just looking at my back. What we've got done is we have power input connected via the, for the live, via the relay in normally closed mode to the switch. From the power inlet to the switch. From the switch to the normally closed relay. Normally closed relay can be opened by the Raspberry Pi once we wire it up to allow me to disconnect the 24-volt power supply because it's noisy. The 5-volt power supply is connected in an always on method, which means that it will always be on to always power the Raspberry Pi, but that's only a couple of watts, so that's no big deal. And we've also connected from the 24-volt output on the LRS 350 through to the CAN bus to allow us to run the CAN bus from there. Next, we need to find ourselves a suitable USB cable for connecting from the Raspberry Pi to the U2C. Let's turn this around a little bit. That's where they went. Nowhere near long enough. That was the one I was thinking about using. It's nice heavy duty. Hi, Penny Rugspin. Sorry if I missed you. You have the BTT power switcher, Delio? No, that was before I started beta testing. So, just a standard high spec, I think this is a 50 watt, 60 watt rated super speed USB 3 cable. Doesn't need to be this spec. It's just that it's got lots and lots of shielding on it. Well, that was more by luck than judgment. The cable the plug only just fits with the bend it needs to make. I could have always opened up a hole in the back of the power supply, but a power supply box, but wouldn't have been ideal. Turn this so you guys can see it a little better. So what we've got going on here is that is the USB that connects to the buttons at the front. This is the USB adapter for the U2C, which is this cable here. So what else do we have remaining that we're going to need to plug in? We're going to need to plug in the screen, and we're going to need to plug in the HDMI. Now, that brings me back to what's Phil been doing off camera. This is yet another revision of my holder box. Ground is green and yellow, just like it is in most countries, yeah. This was the box version that we were using last week. I realized that the tie strap loops were actually coming out underneath the buttons, the plugs for the stepper motors, so they were in the wrong spot. So what I did was I pushed them across, and we also found last week that the HDMI and the power inlet ports were too small. So I went away and I modified my box to allow that. Where is my HDMI cable? It's here somewhere. I saw it earlier. It's always in the place where I put it down, isn't it? There. Now I am going to go and buy myself a shorter HDMI cable, I think, but this now does fit. And we can plug it into the screen. And we're going to need ourselves a USB cable. Now I'm thinking for now, the screen can sit up there. It's probably not going to be its final living position. But that means that that cable is long enough and I don't need any more extensions, and I can plug it in just here. Now the last cable we need, it's not that one, not that one, that one. And this is where we find out if Phil screwed up and made his cable run not the right length. Ah, that will fit. Ta-da! Okay, so where are we at? We have the touchscreen and the HDMI plugged in through its power USB and its HDMI port. We've got the front buttons plugged in, and we've got the U2C plugged in. In principle now, we could boot this sucker up. Let me find a power cord. Now, of course, it is going to error because it's got no... what am I saying? It's got no toolhead, thermistors, etc. It's going to immediately crash. But we are getting very, very close on this, thank goodness. And we've got 30 minutes before I have to end the stream, so let's move on to this. Now, power cord now for this modified way of doing things comes under here and in through here. Now you can't see because I've got the divider glass, but it connects here. Now the power switch is here. Are we ready? Are we going to get magic smoke? Be ready to clip it. Be ready to clip it. Green light's there. So the 5-volt power supply is getting power. Why isn't the 24-volt power supply getting power? Or is it? No, it can't be because its fan's not come on. I can't believe that I've done anything that would toast it. Okay, let's do some safe troubleshooting. Power off. 240-volt power disconnected. Let's turn this so you guys can see it a bit better. Remind me, guys, that the power cable is over there next to the filament dryer. You guys probably won't be able to see a lot of what's going on the screen. Oh, it looked better than I thought it was going to. Does it work here? Not really well. Let's see if we can adjust the camera. So we have, at this point, got our 240 volts disconnected, and I've completely removed the cable from the unit for safety. I'm going to set this into AC mode, auto ranging, and I'm just going to touch across the live and neutral and make sure we've got nothing here. There we go. You can actually see it. It's down to 12 volts across there. So there is residual voltage sitting there. As I mentioned earlier, it's a good idea to not just grab these terminals. Those two. And wait, so I'm in non-continuity mode, guys. It's going to beep when we have continuity. So what I'm doing at the moment is we have continuity across the relay. So that's good to know. Let's see if we have continuity from the 5 volts power live to the, we have continuity there. And from the neutral to the neutral, no neutral continuity. So what I'm doing is I've got the neutral of the 24 volt power supply to the neutral of the 5 volt power supply, and there's no continuity, which means that either the connection at the Wago is not working. Actually, it can only be that. Because of the way we have this wired, it can only be that. What I've done is I've just quickly removed the earth wire from the power inlet, just to give myself a little bit more room to see what's going on. And now that simply the act of closing the latch accidentally pulled the wire out. There we go. Let's get my screwdriver. Jeremy's probably sitting there killing himself laughing at this. So let's see if we now have continuity. So again, from the neutral on the 5 volt power supply to the neutral on the 24, no continuity. But why not? Could it just be a bad Wago? There. And what I'm doing, guys, is I've just got myself a... Get rid of that. It's a bit too bright. Those in glass houses. That is securely seated. So that is the positive wire I'm currently using. Let's connect the negative wire to the other end. And let's measure for continuity across the two. And that's connecting. It just must be the way I'm inserting this into the connector. It's not very good. Let's make this as easy as possible. Let's do it outside of the holder. So the 24-volt power supply is connected, the power input is connected, and I've just done the 5-volt power supply connection again. Let's redo this continuity test. So continuity from the neutral on the 5-volt to neutral on the 24-volt supply. Way goes back in its little perch. Connect the safety earth. Just having a look at everything here, make sure I'm happy. That's all looking good. So make sure all our fingers are out, make sure all our wires are safely protected. Turn off the fluke. One of the best $10 I ever spent was this fluke. It was on an auction site after a mine site closed down. And nobody bid on it. The only downside is its screen isn't particularly bright. So, main switch is off there. Double checking again, make sure there's nothing live that's exposed. And on. And we have a blue light. I don't know if you guys can see it, but we have a blue light now on the LRS 350. And if I find my lapel mic, the noise reduction doesn't allow you to hear it, but that's quite a noisy fan. But that's all in place. So, where are we at? We have CAN bus power connected. The CAN bus power light is on the U2C. We don't seem to have any power coming to the Raspberry Pi, which is normal. We haven't yet connected the 5-volt power for the Raspberry Pi. Let's shut that down very carefully. And what we need to do now is make up a wiring harness for the Raspberry Pi. There. So, this is where I'm going to explain a few things to you about what's going to happen afterwards. This is a Type C power tail. It's good for 5 amps. And this is going to be powering what's going to go in here after the I'm allowed to show you guys all the new hardware. So that is something that I need to keep safe. And that's the reason for the 5-volt power supply going here. That's there, that's there. Next. How am I going to power that easily? I know I have an SKR Pico power cord. So that's normally the 5-pin connector that connects the serial and the power to from the Pico to the Raspberry Pi. My proposal is we make up an extension for this, which connects to here and connects to that. So we are going to need, actually, why am I even stressing about this? I've got so many of them and I never use them. Now, why am I not a fan of these cables? These cables are using the DuPont connectors on the Raspberry Pi for the GPIO to get power to the CPU on board. What that does is it bypasses the protection that's built into the power input that's normally the USB jack on the Raspberry Pi. And by bypassing that, you're then losing all the smoothing that the regulator provides and a whole bunch of other features, including overcurrent protection. And am I overthinking this? Yes, I probably am. I have some better wire for this. This. It's the same kind of cable that they use on NeoPixels a lot. It's got the red power, green signal, and white for ground. And the reason I'm using this is I'm going to then have a third wire that's got signal available to feed to the relay. Because from this 5-volt power supply, I can also power the relay, which means that I gain some efficiencies in the amount of cables I have to run. Let me just check the time. I've got about 10 minutes left. Okay, this will wait until next week's episode. So where are we at? We've done the CAN bus cable up ready to mount this. We have mounted all the electrical stuff into the electrical bay. We didn't yet mount this to the carriage, which we will do right this moment. One. Two. And I need one more M36. That's an M2.5. That can go back into there. Oh, I should probably move the camera up so you can see what I'm doing, shouldn't I? Up. There we go. Sorry, guys. The right one? That's the right one. So what this adapter does is it just uses the existing M3 screw screw mounts that are already built into the carriage. So that's ready to go. So then this, as long as I'm careful when I put it into place with not crimping any wires, holds the tool head into place. We've got the ability to mount the CAN bus as soon as we're ready to. CAN bus will connect into that, and it should be all ready to go there. So that's good. Now, lastly, remember at the beginning of the stream we were talking about the HBB macro buttons. This is the shell. Let's go to here. And nobody wants to count the pimples on my face, so let's go there and up a bit more. Macro buttons. Into the slot. It goes that way around to allow the 5-volt power socket some space. Now, this is a good enough fit that it could just be left as a snap. Just check something. Yeah, it's designed for M3s, just threading. I was just checking it wasn't set up for heat set. So I think these were M3 8s that it needs. No, please ignore the state of that print. I realized I'd accidentally knocked the load cell in the Prusa when I started the print. And as a result, it started about, probably about 0.05, maybe 0.1 too high. Now this is such a secure fit already that I'm not going to bother putting all 4 screws in. It's possibly only a temporary thing while I experiment anyway. Now these are just the buttons that I printed when I was playing with when I first got it. So these will get new buttons printed in the not too distant. And Mrs. Maker and the kids are away this weekend, so I might do an ad hoc stream, either before Steve builds or after Canuck Creator, one of those. And we'll have a play with this and set it up probably. So that's that translucent green sediment that I was telling you guys about. It allows you to see the infill. It looks kind of cool. It doesn't show as well on the camera, I don't think. Oh, maybe it shows all right. So let's have a quick look over at the Voron now. And wait. And a little bit of zoom. Don't forget to give a thumbs up, as I almost forgot. Everybody should thumbs up, everybody. There's nothing more disheartening as a YouTuber who knows how the metrics work, well, as much as anybody can know how YouTube metrics work, seeing a stream that's going and there's 50, 60, 80, in Steve Build's case, 200, 300 people on the stream, and there's less than half of that in likes. But then you see all those people have entered the draws, without doing a like, and I consider that's just plain rude. If you're there for the draw, leave a like. It costs you 10 more seconds, well, not even, to click that button. It's right next to the clicking more to get to the link in most cases. Yeah, and the more people just spam random crap in chat, the better, because that's engagement. So I know people see me spamming randomly into chat on various people's streams. That's interaction. That's getting those guys more dollar bills. Do them a solid chat. Even if that chat is reminding other people to hit like, you're doing them a double favor then. So, where are my T-nuts? 2.5 hex nuts, M3 washers, hammerhead T-nuts in M3. Yeah, exclamation mark fart, that works. And lots of emojis, lots and lots of emojis. Where are we at time-wise? 3 more minutes, just enough time to screw this to the front of the unit, I think. Is it the right way up? Yep, it's the right way up. Not that it actually matters. One. Two. 3. 4. And that's all secured in place. So, tell Mrs. Maker we say thanks for helping you stream today. I will certainly do that for you, Nick. She is a rock star and a legend. Let's get those out of the way just in case I bring Ryder in here to tidy up and he gets his paws on them. And those as well, because they will go everywhere. It's not so bad if he knocks these screws on the floor, because they're magnetic. But the crimps, if he knocks those on the floor, they're aluminium, so you can't clean them up easily. So, what have we done today? We have put in the 5-volt power supply. We have rewired the 24-volt power supply. We have connected the U2C. We have crimped up the CAN bus cable, and that's ready to plug into the toolhead board. We've mounted the carriage converter onto the end of 5, ready to mount on the Rapid Burner next week and connect to the CAN bus. So next week is going to be, that's better. Next week is going to be the, nobody needs to see me that much. Oh yeah. Next week is going to be wiring and software by the looks of it. Fingers crossed that CAN bus cable just works and we don't have to re-crimp anything. I'm pretty confident that I got it right. So, I have been Phil, I have been the Down Under Maker, and it's time for me to hop on out of here. Bye guys!